Guys, good afternoon, man. Am I audible, man?
Yes, sir.
Tell me, man, am I audible, man?
Yes, sir. Audible, sir.
Okay. Out of 80 students, only 50 plus have joined. If your friends have not joined, ask them to join immediately, guys. Okay. We will start our class. Sorry, suddenly it got disconnected. Let us see now. I don't know where got disconnected. Okay. Last class we have seen about the PLC, the architecture of PLC. It is about in Unit 4. The first topic is PLC. Okay. This PLC is an important device for automation. This PLC will help you to get decisions. It will give you the priority and make the automation to run smoothly. So with PLC, you can make a low-cost automation. Without PLC, the automation is possible, but when you use PLC, the low-cost automation is possible. That is why it is one of the best option for us. So in that, we are looking about the architecture of a PLC system. See, the PLC system is have a very simple architecture. We have an input module and the output module. We have input module and the output module. In between, you have a CPU. The CPU is nothing but where central processing unit where it will take some decisions according to the program and the data. It will take some decisions. Okay, and the input module and the output module is separated with the optical isolation. Why it is optical isolated is in case of any input when the input value rises, that means input rises, it might affect the CPU. It might affect the CPU. So it will to have some safety. It is optically isolated. So when you get input data through optical, that means through light, it will transfer the data to the CPU. So once it has been transferred, according to the program, it will have some logic and data, and that data will be transferred optically to the output module. Then it will be transferred to the output device. Okay. Here the CPU is connected with the programming device. That programming device may be CPU, a laptop, maybe a tablet, whatever it might be, through which you can write the program and send to the CPU. According to that logic, the CPU will run. So this is how the PLC will works. Okay, and it have its own power supply. Okay, each will have own. Each will get the power from the power supply. Okay, so this is the architecture of the PLC. This in detail in the last class, even positive advantage, disadvantage, everything else. So next topic is PLC scan cycle. How it will scan and how it will run. So when it gets input, so then input will be processed in the CPU. So it will compare the CPU will compare the output and the input and the output. If that varies, so it will take the necessary action by giving the output signal, so that the motor runs, the light will, the alarm will give signal. Likewise, it will happen. Okay, so this is how the PLC will work. Once it get output, again that output will be again checked, and it will get a feedback, and it will give us an input, and again it will check. So this cycle will keep on repeating until the desired output is achieved. So this is what the PLC program cycle. It will get input, it will have a decision, and it will give some output. That output will be again verified, and it will given as an input. Then again this process will. So this is how we will get an accurate output. Okay. Next one is how to select a PLC. This topic we have seen in last class depends upon the number of input and output. There are the automation area will have a maybe small and large. So depends upon that you can choose. Depends upon the input and output, you can choose the PLC. Next one is processor, memory, and bitrate. The speed which you have required, how much memory you need. depend upon that you can choose. Next one is the type of relay or transistor which you are going to use. The processor you can choose. Next one is resolution. Resolution means I have told you it is the for how much small input it is responding. So depends upon that you can use. If you want PLC with even react for an you can choose accordingly. For sometimes you can choose for 1 centimeter. So depends upon that you can choose the PLC. And last one based on the brand. As you know, man, when you type PLC brand in Google, you can get many different types of brand. According to that, you can choose. So these are the things which you have seen on last class. Now what you are going to see is ladder program. See, this PLC will run with certain logical condition of the program. That program is nothing but ladder logic program. So what is ladder logic program? Let us see about the ladder logic program today. Next class, we will try to write the ladder logic program, and we will in that way we will slightly improve the complexity of the ladder logic. Okay. So first, we will see what we mean by ladder program. What is ladder program? It is a primary programming language for PLC. It is a programming language for PLC. Not only ladder programming, there are 4 different types of programming methods used in the PLC. First one is FBD, function block diagram. That is the first type. Second one is structured list, that is ST, instruction list IL, sequential function chart SFC. These are the 4 other PLC program we are used for. Out of this, the very common method is ladder logic. Out of this, very common method is ladder logic. PLC is a logical controller which has terminal for input and output. The relationship between these input and output controlled via control logic. That control logic are programmed by different languages which I have shown. These languages is visual and graphical languages. It is not a language like C or C++. It is a visual and graphical in nature. Okay. It is derived. It is also said to be a derived form of relay logical diagrams. I will show you why it is a different form of a derived logical diagram. I'll show you. So these diagrams are based on the we will draw with some basic based on the gates, logical gates. In the gates, there are 3 type of gates are most common: OR and NOT. These type of gates you might studied in your school itself. Even though, let us have some brush up. Okay. Okay. So what you have seen here is a ladder diagram, ladder logic diagram. So now you might understand why this is called as a ladder logic diagram. It might looks like a ladder. That is why it is called ladder logic diagram. Okay. Here you have to note it down that the input condition, input instruction, and next one is output instruction. Just a moment, boys. Sir, சொல்லுங்க சார். ஆமாங்க சார். Okay, can you class போயிட்டு? Sorry guys. Here the input instruction here you can see here A, B, C, D, E, F, G, H, K. These are the input instruction. You might indicate with the letter A, B, C, D, or A, or depends upon the your understanding. Okay. Next one is output instruction. So it is indicated in some bracket. You might in that bracket you might write it as a B, M. Depends upon your output. If you want to switch on the motor, you can indicate here as a M. If you want to open or close the valve, you can indicate it here as a valve. So it is for our understanding. Okay. Next one is you have to note it down. Here the horizontal line will be called as a runs. In that input instruction is placed. The horizontal line, this line will be called as a runs. Okay. The vertical line is called as a power writes. The vertical line is called as a power writes. Okay, you have to note down. These are some of the terminologies we use here. Here you also note down that the path should be flowed in a continuous manner. The path should be flowed in a continuous manner. It might be break for the logical gate indication. Other than that, it should be a continuous path. Okay. Okay, then we'll go for next. So, what are the important rules to be maintained while drawing the ladder logic? Or else the important rules. Second one is output on right side cannot be connected directly with the left side. Yes, of course. The output on right side is not connected directly with the input. See here, this is the output. It cannot directly connected with the input. Okay, that output may be utilized for running with other logic, but it cannot directly connected to the input. Okay. I'll take the attendance right now. Boys, only 78 are there. I think 82, 84 have to come. Let us, if the number increase, I will take the attendance once again. Okay. We will continue, man. The power flows from left to right. The power flows from left to right. The output of the right side cannot connect it directly with the left side. Contact cannot be placed on the right of the output. Yes, your contact cannot be placed on the right of the output. This rule is similar like your previous one. Okay, in that contact, if you directly cannot connect with the output, it has some logic. Okay, then each rung contains one output at least. Rung means I have told you horizontal line. So each horizontal line will have at least one output. Okay. Next one is each output can be used only once in the program. So one output can be utilized as only once in the program. Okay. Next one is a particular input and analog output can appear in more than one rung of a ladder. So the output or input, it can be appear in number of times because it depends upon the logic. We can replace the same input for a different area. According to that, it will have some output. Okay. இப்போ ரெண்டு மூணு கண்டிஷன்ல வச்சு நம்ம என்ன பண்ணலாம்னா ஒரு அவுட்புட் வந்து கொண்டு வரலாம் இல்லையா? அப்ப நமக்கு வந்து இன்புட் வந்து ஒரே இன்புட் வந்து ரெண்டு மூணு இடத்துல வரலாம். So that it indicates that a particular input or output may appear more than once in a rung of a ladder. Then input and output are all identified by their address and notation used depending upon the PLC manufacturer. So in the previous slide, I have told you that the input instruction with A, B, C, D, and output with some out 1, out 2. So these are the things which will be indicated depends upon the type of manufacturer. It cannot be always same every time. It depends upon the manufacturer, depends upon the PLC you are choosing. Okay. Next one is what are the input devices you have in PLC? I have told you already that we have separate terminal for input and output. So what are the input devices we have? First one is limit switch. So this is what the limit switch is. It will have contact or no contact. In that way, it will interpret with the PLC. So when the switch goes ups and down, so it will have contact and contact. Next one is a photo detector. So photo detector, as you know, this is nothing but a sensor. Next one is push button. So this is the push button. So here you can apply pressure or not. So it will interpret the on or off. So this type of devices will give you input as a on and off. Second one is timer. So here, see here, it has some digital timing. So even these type of timers are used in domestic itself. Even in home, if we have some compound light, compound room light, if you set a timing of evening 6:30 to night 9:30 or 10 p.m. So when the clock runs internally, when the time reaches about 6:30, it will automatically switch on, and by 10 o'clock which you have set, it will automatically switch off. So it is this timer will give you the on off interpretation with the PLC. Next one is control relay. So this control relay is nothing but it will control the flow of current. So when you have contact and non-contact, depends upon the flow of current will be. Last one is circuit breaker. So circuit breaker, as you know, this already you might see when you have a low voltage or high voltage, it will break. So depends upon that, it will give the input to the PLC. So these are the some basic input devices used for the PLC. Next one is binary output devices. What are the output device might be? Okay, for example, motor. So the motor. The first one, what happens when you are filling the tank? Once it gets filled, you have to switch off. When it goes beyond, when the water goes beyond the certain level, you have to switch on. So the motor will on off condition interpretation with the PLC. Then next one is alarm buzzer. Sometimes when you have some bad situation, the alarm have to buzz. So likewise, it have on off condition. Next one is light, likewise on off condition. So when you take CNC machine, which you have seen in the CNC lab, you might see the different lights will on depends upon the condition. When there is an emergency, what happens? The red color light will switch on. Likewise, the light will have a light on off will have an interpretation of the yes. Next one is control relay, valve, clutch, and solenoid. So these are the some basic output devices will be connected with the PLC. Okay. Next one is anatomy of a ladder diagram. So this is the anatomy of the ladder diagram. See here there are rung 0, 1, 2, 3. So these are the input instructions and these are the output instruction. These are power rails. Okay. So this is how the ladder anatomy will be. And what are the conditions it have? So input instruction are entered on the left, output instruction are entered on the right. Okay, as you indicate, as I indicated earlier, the same thing will be. Next one is the power rails simulate the power supply rails. Okay, so the power rails will simulate always the power lines. You have to note it down that L1 and L2 for AC circuits and 24 volt and ground for DC circuit. So it have plus 24 volt. Most PLC allows more than one output per line. Okay, as I told you, only one minimum it should have one output. Without an output, you cannot draw the run. But most of the PLC, you will get more than one output per run also possible. These types can be applied when you have some complex thing to have in the PLC. If you have more than 10 microprocessor to control the automation, it has some complex parts. So at the time, it will have some more than one output. The processor scans ladder run from top to bottom and left to right. So this one you have to keep in mind that the processor, the PLC will read from left to right and top to bottom. So this is how it will be. We have to keep in mind, and according to that, we have to draw the logical ladder logic drawing. Okay. Even it have you can in exam wise you can draw the ladder logic drawing, but for writing program for PLC there are many softwares. In that you have to prepare the ladder logic drawing, and you have to connect with the, and you have to send those ladder logic to the PLC. Okay, as I told you, which you have some external device through which you can connect and send the program. Next one is basic ladder logic symbols. So these are the symbols which we will use while on drawing. First one is normally open contact. So this is normally open contact. It might look like a switch. So when we draw this, it is normally open. Next one is normally closed contact. Normally closed contact. So when the switch closes, so it will be drawn in a such a way. You have to note down, boys, when you have normally open contact and normally closed contact, it will be usually drawn in the ladder logic. But when you energize and you give the input, this terminal will changes its own condition. When you have normal open, it will change to normally close. When it is indicated in normally close, it will change into normal open. It also indicated in NO. This normally close also indicated in NC. Again, I am telling you guys, normal open contact is it doesn't have a contact. Normally closed contact means it is closed using this contact. Okay. When you supply input, the condition what it has will be reversed. Okay. When you have normally open contact, when you give input, it will be changed to normally closed. Likewise, in normally closed contact, when you give an input, it will change to normally open. Okay. This logic will be used many times in our ladder logic program. So keep this in mind and don't forget. Next one is output or coil. So this is how the output will be indicated. Not output or coil. So this is how the indicator. Here you also note down, boys. These type of symbols are used in Allen Bradley. So this is one of the popular ladder logic program. As I told you, in PLC there are many different types of ladder logic program, and so many types of program are there. In that, one of the popular one is ladder logic. In that ladder logic, there are many different types of that. The most commonly used are Allen Bradley. Okay, so we will see program according to the Allen Bradley. Okay, according to these symbols and according to these notation, we will see. It is commonly used. That is why we are going in that way. Okay. Next thing you have to note down is in a PLC program, the thing is it will be either true or false. As I told you, normally open, normally close, it will change its condition. So that is when it is open and it is changing into close. When it is close, it is changing to open. That is nothing but it is, when it is true, when you give input, it becomes false. When it is false, when you give input, it becomes true. So likewise, the input will be either true or false. It is getting signal or not. Likewise, okay. If the proper input conditions are true, then run becomes true and an output action was. Okay. If you want an true condition, if that gets true, so that they run in the run, the current will flows and you will get output. Okay. If the proper input condition is not true, then the run become false and the output does not acquire. So when you write a program, you will give a condition of true or false. If you give it true, the signal will flows and you will get output. If you give the condition as false, the condition due to that the current will not flow and you will not get any output. It will move to the next line. So this is what you have to keep in mind. Next one is we have seen about the ladder logic, some of the ladder logic basics or some of it. Now we are going to see the gates we are using in the ladder logic. I think There are 7 different types of gates are available. Okay, and or not, NAND, or exclusively or and exclusively not. So these are the 7 different types of gates which are used in the digital system. Okay, even for PLC, the same 7 types of NOT we are used. Okay, the electronic gates require power supply to run. Without power supply, it will not run. So these gates require power supply. So the gate inputs are driven by voltage having 2 nominal values. That is, one is 0 volt, another one is 5 volt. So plus 5 volt. As you remember, while studying the analog to digital converter or digital to analog converter, we have studied about the output. In that, the analog signal will be usually in plus or minus 5 volt. If that input is analog, it will be 5 volt. If that input is analog, that will be 5 volt. If that is binary, it will be 0s or 1. Likewise, the PLC is used in both conditions, both analog condition and digital condition. If your input is digital and if you want to control a motor, you need a analog, so that this condition can be run by the PLC. The same thing can be reversed. If you have an analog signal for the input and if you want that as a output condition as a digital, that is also possible. Okay, so these are the things can be done with the help of converters. So for all the conditions, the PLC can able to work. Okay, so next thing is the gates. To understand the gates, we should know about the uh, truth table of that. So the truth table will show the what function the gate can do, what logical operation the gates are working. So let us see the truth table of that. Okay, before going to that, these are the basic gates which are used in the PLC programming, ladder logic programming, and or not. So this is how you will indicate the and not, I'm sorry, or and not. So AND gate will be drawn in the logic in the PLC ladder logic in this way. Okay, and for OR and for NOT. I will quickly go down. I will explain the next slide. Okay. So this is the AND gate. See here, you have a two input one and input two, and according to some logic, the AND gate will give some output. Okay. What logic it input one when you have input one is 0 and input 2 is you are getting signal, even though output you won't get any output. Okay, when you have when you have signal in input 1 and you don't have in 0, you will get again 0. The AND gate will give you some output. When you have input for both 1 and 2, it will have some output. So that is why it is called AND gate. AND gate na input 1 and input 2, and input 1 and input 2 you get signal. You will have, it will be processed and it will give some output. So this is what the AND gate is. So this AND gate can be drawn in the ladder logic in a such a way. See here, it is input 1 and this is input 2 and this is the output. Okay, so when you get signal in both A and B, you will have some output. Second one is OR gate. OR gate is it is exactly opposite to the AND gate. In AND gate, what I told you is if you get signal in both input 1 and 2, it will be processed. Here it is totally reversed. Here, when you don't get any input, it will not process anything. When you get input in either 1 or 2, it will be processed. It will be processed. And also, if you get input for both, also it will be processed. So this is the logical condition of the OR gate. So in AND gate, both 1 and 2, if you get signal, it will be processed and it will give you output. But when you take OR gate, it will be processed when you have either one input. If you get, you will get a output, and also both signals you get, also you get a output. So this is what the OR gate is. This is what the OR gate logical operation, and this is the truth table of the OR gate. Okay, this OR gate can be indicated in a ladder logic with this symbol. See, this is A, and this is B, and this is out. So when you get output either A or D, you get signal, you will have some output. So this is what the OR gate is. Next one is NOT. NOT is nothing but when it's very simple. When you give a closed condition, it will open. It will be open. When you get signal, it will be open. When you get an open condition, it will be closed. That's all. So this is for the NOT. The simple thing is when you don't get signal on both, it will be off condition. When you get signal on A is I'm sorry, man. If you just forget this, you just forget this. Okay, when explaining about this is a little bit complicated. When with this single one input, I will explain. See here, you forget A, man. In this drawing, you consider only B you have. In that you have a normally closed. Okay, in that you have a normally closed. When you get a signal here, this B, what it will do is the normally closed will change to normally open. Okay, normally open, so that the signal flows and output you will get. When you have a normally open condition, what will happen is the normally closed will change to normally open will change to normally closed, and the output will not, you won't get any output. Okay, so this is how the NOT gate will works. Just a moment, man. Guys, are you following, man? Boys, are you following? No response, man. Okay. So another 5 minutes we will complete, man. As we have wasted 5 minutes because of net, I will complete. I will complete in another 5 minutes. Okay, please listen. See here, these are the schematic representation, truth table, and Boolean notation of the gates. As I told you, there are 7 important gates. So this is what it is. So NOT gate is what is. When you have 0, it will convert to 1. When it is have 1, it will be converted to 0. So for this, the Boolean notation is Q equal to A bar. This might be written as a Y. Even instead of Q, they might written as a Y also. Okay. Next one is OR gate. The OR gate is nothing but Q equal to A plus B. Okay, Q equal to A plus B. So 0 plus 1, what you are getting? 1. 1 plus 0, 1. 1 plus 1 is 1. Okay, since it's a binary. So this is what the Boolean condition of OR. Next one is Boolean condition of AND is Q equal to A dot B or AB. Okay, since there are 2 input, so it is Q equal to A dot B. So these are the group 1, because these are the basic things. That is why it is indicated in group 1. Next one is group 2. Group 2 is NOR and NAND. See, NOR is nothing but on combination of NOT and OR is called NOR. NOT and OR combination will be called as a NOR. In that, see here, in OR what you are getting, the truth table 0, 1, 1, 1 condition. So in that condition, you are applying the NOR, and you are applying the NOT, so that the condition is reversed. For 0, 0, it will be 1. For all other condition, it will be 0. So it is the opposite of the OR condition. So it is indicated in Q equal to A plus B whole bar. Next one is NAND. So NAND is a combination of NOT and AND. AND is a combination of NOR and. So it is a combination of NOT and. In that you will have and truth table, and reverse of that is the NAND condition. See here, you are getting signal. Once you have in both signal, both input A and B, you have get signal, you have a output. So reverse of that will be the NAND. So for all conditions you have signal. When you will not get signal is when you have signal for both input A and B. So that is what the NAND gate is. So Q equal to A B whole bar. Next one is XOR or exclusively, or sometimes even they will write as a EXOR. So it is a special type of gate man. In that, so it will have some output. When you have input in either A or B, it will give some output. On all other conditions, it will not have output. So this is what the condition of the OR. Okay. Boys, in exam, sometimes they will ask you to draw the schematic representation of the gate. Sometimes they will ask you to write the Boolean condition. So both Boolean notation, both you have to able to know, and so that according to the question you can able to write. Sometimes they will ask you to write the ladder logic program and the Boolean notation of the program. So you have to be very careful on knowing this. Next one is so how to draw the relay to the ladder diagram. See here. See here, this is the neutral one, and you have a switch A and switch B. So it is connected to the lamp. This lamp will lights once both A and B is closed. So that is equal to the condition of AND gate. So it can be drawn here as a such way. So you have drawn the power rail, and you are going to draw the run in that two input A, B, and you will have output. Okay. So sometimes this can be drawn. You see here, the condition is if the lamp will lights either condition A or B gets signal, it will be lights. So it can be drawn in a such a way. Okay. So AND gate and NOR gate. See here, the same AND gate also drawn in a such a way. When you have a signal in A, you will get a AR. When you have a signal in B, you will get a BR. When you get both AR and BR, it will be combinedly called as a LR. That signal, when you get LR, the lamp will lights. So it is equal to the AND gate. So it can also be drawn in such a way, but you no need to go for such a complex thing. By drawing such a simple notation is enough to express your ladder logic drawing. Okay, so this is how you have to draw. So the diagram shows that when you have some complex logics, the ladder diagram will be in such a way. See, there are many inputs and each have its output. The power rail is here, the AND is drawn here. The PLC will go through from top to bottom and left to right, and it has some timing for giving the output. So this is how the ladder diagram we have to draw. So we will see some of the ladder drawing, how we can draw for some examples on next class. Okay. Thank you for listening, man. If you have any doubt, you please ask me.